All right, part two for the electromagnetic spectrum. We were talking about light, invisible light, in this whole region in here. All right, and we said that these aren't really the 7 colors, it's actually a whole spectrum of colors. All right, now how do we see colors? We talked about earlier about the white stripe that's on my shirt. Well, how do you see something that happens to be in one of the frequencies of red? Well, what ends up happening is light comes down and it has this whole area of frequencies. And the one frequency that is a red color, that will bounce off of the material and it bounces back to your eyes, and you see that frequency. That frequency in your eyes is determined as red. All the rest of the frequencies that are there, they actually get absorbed into the material and you don't see those. So if you're wearing an orange shirt, a bright orange, then you're going to get the frequency of bright orange out of this area, and that's what's going to bounce back at you, and all the rest of them are going to be absorbed. What if I see white, like the line on my shirt? Well, that's bouncing back all of the colors, and we get all of those colors bouncing back, and we see white. If all the colors are absorbed, then you see black, like the rest of my shirt. Something that's really cool to try, and I know Lowe's has one of these over in their paint area, is they'll have a spot where they have like 3 different lights that you can take the little paint strips and stick them underneath. And you can look at them and see. And what's really kind of cool is that they have different light fixtures. They'll have a fluorescent bulb, regular bulb, they'll have a LED bulb, and you put them underneath. And the interesting thing is you take the same stick of paint and hold it underneath, and you'll see that it'll change color underneath each one. And the reason for that is because light bulbs do not give off all of these frequencies in there. They might leave a couple of them out. And if those aren't in there, then those aren't going to be able to bounce back. You're not going to see them. So that's why we see the colors change based upon the kind of light that is placed down on something. It all depends upon which frequencies we see bouncing back at us. All right. Now we go above this, and nope, there goes my things, but it's okay. It's not too bad. The next region, this is ultraviolet, or UV rays. Ultraviolet rays, these are the ones that, we can use to get a tan. They also unfortunately cause cancer if you're exposed to them too much. So these ones over here, all of a sudden now we're running into the ones that actually start to cause problems if you're exposed to them. Everything below this doesn't really, as far as we know right now, other than the microwaves, and even those we're really thinking probably don't, but those don't cause problems because they're a low enough frequency over here, right? When we get to ultraviolet, we start running into problems where they start to become damaging, right? Something else to know, I wanted to wait until I got to this point, is if you have ultraviolet lights in your house, what do they look like? Don't they look purple? I will tell you, you actually can't see UV light. Ultraviolet light is invisible. Our eyes can't detect it. So why is an ultraviolet light purple? Well, the reason for that is because they bring in this region right here. And when they bring in that region, it actually brings in a little bit of this visible light, that violet area, the purple piece. So we see that violet or that purple color. And that's why ultraviolet lights are purple. Now also on that, probably when we're watching this video, it might be cold outside because it's probably going to be starting to get near the winter time. If you have a heater on, those heaters actually, like little space heaters, look what color? They look red. Well, what are they giving off? They're giving off heat, which is infrared. Well, infrared, again, is invisible to us. But what happens is we end up with a little portion of the visible light being part of that. And what portion of it? Right here. We end up with the red portion of it. So because the red light is part of that, then we see it as red. You don't usually see a heater come out blue or green. They don't come out that color because that color is too far away, so they don't get that. Same thing, you don't get ultraviolet lights coming out green or yellow, right, unless we paint them that color. All right, so it all has to do with those frequencies of light. Now, if we go to the next region is X-rays. X-rays, are those damaging to us? Yes, they are. They are if we get a lot of them, right? For you to go in, if you happen to unfortunately break your leg today or break your arm and you go to the hospital and you get an X-ray, that little bit of X-ray isn't going to hurt you, right? Because it's just a little bit. Same thing, you go to the dentist, they take X-rays of your teeth. That little bit of X-ray doesn't hurt you. The person that it hurts is the person that's doing the X-rays, and they do it all day long for 8 hours a day, 5 days a week for 30 years, right? When you do that, if they're exposed to it every single day over and over and over, then they can get enough x-rays in their body and it can be damaging to them. Now, one thing that I want you to look at next time you're at the hospital is notice their ID that they wear on their like their clothes. And usually you'll see somewhere in the corner, one of the four corners, there'll be a little spot that has a little square that's a little different color. And what that actually is, it's a piece of film. And as that film is exposed to x-rays, it changes color. And they know by looking at their ID that if it's starting to change color, they're getting too many x-rays. And what they need to do is they need to take some time off from their job to lose that x-rays that they've been part of. Now you might look at that and go, well, sweet, that's an awesome thing. I like make sure my ID gets exposed to that so I can get some vacation days. But the reality is, no, you made a mistake. And the mistake is you shouldn't have been exposed to those x-rays because you're not doing your job right. So those vacation time that you're going to get isn't going to be vacation. It's going to be time off without pay because you're not following the rules. And the rules is think about when somebody takes an x-ray of you, where do they go? They leave the room and they go hide behind a wall, big brick wall, to protect themselves so that they don't get x-rays and therefore they don't end up exposing this film and they don't expose their body to it so that they get problems later on. Right? So that's something else that you can notice out in the real world. Now, where did the word x-ray come from? I read about this and I thought it was really interesting. That was the guy that was studying about x-rays. He had a substance and he was down in his basement and he noticed when he opened up the canister, all of a sudden he noticed that some film that was laying there changed colors. And he thought, wow, that's really cool. So he went upstairs. This is a true story on how this was discovered. This guy went upstairs and got his wife and brought her down and took her and put her hand on top of the film, not knowing anything about what was exactly going to happen. But she put her hand on the film and he opened up the canister and said, watch this. And she took her hand off the film. And what did she see on the film? Her bones. And oh my God, she freaked out and started screaming. And why did she scream? Well, this happened a long time ago, and the only time that you would see bones on a person years ago before we had x-rays was when a person was dead. So this guy's wife thought that her husband had made it so she saw her death before it ever happened. And it made her scared, and she ran away and started screaming and everything. So this guy, he looked at us and he's like, oh my gosh, there's something coming out of this, and I don't know what it is. I have no idea. Well, if we're going to math class, and you have something in math class that you don't know what it is, what do we call it? An unknown is X. So he said, well, some X-ray, an unknown ray. So that's how X-rays got their name, was because it was an unknown ray. All right, so let me go to the next one, the last one. This one's called gamma rays. And gamma rays, and I'll move my head over so you can see it. Gamma rays, these are the most damaging. These would be the type that come from nuclear bombs or nuclear reactions. We do use some of them over in this region, and we will expose people to just a little bit of it, and we give them just a little bit of it to try and help cure cancer. The only thing is, obviously, these things are damaging, so you don't want to give the patient too much because then it can be too damaging on the person. So we have to control how much. And a lot of times when people get this, it doesn't make them feel very well because it is poisonish like to the body. It hurts the body, so it doesn't feel real good. We work our way across and get over to these other ones where they have a really short wavelength and a really high frequency. These are the ones that were used in nuclear bombs, and they're have so much energy that they make things just burn up and explode, and it's really, really, really damaging. So again, as we go from here, it's really long wavelength. As we work our way across, the wavelengths get shorter and shorter and shorter. So we get all the way over to here to have really, 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 really short wavelengths and really, really high frequencies. Right? That's what the electromagnetic spectrum is. Now, what in the world does all of this stuff have to do with chemistry? Well, that's what the last piece of these notes are all about, is apply it to chemistry, number 5. Well, elements, when we heat them, they absorb energy. Now, the way in which I like to describe this, think you're sitting by a bonfire and you're going to cook some hot dogs on a hot dog fork. So you take the hot dog fork and you put it in the fire. And you hold it in the fire, hold it in the fire, hold it in the fire, hold it in the fire. You take it out, what's it look like? It's red. It's red and it's really, really hot. So why does it do that? Well, number one, when it cools, it loses energy in two forms. It loses it in the form of light which happens to fall in this visible light region, specifically a frequency in the red area, sometimes all the way over to the orange. But the interesting piece is on that hot dog fork, no matter how long you put it in the fire, you'll never get blue, indigo, or violet. You'll never get to that point. You won't get green out of it because it doesn't emit that frequency. Now, the other thing that you'll also notice is it's hot. Well, what portion up here is hot? Infrared. So it's also giving off infrared waves. So we feel heat, and we see this one of these frequencies or some frequencies in the red and orange area for that hot dog fork. So why does iron go red when it's heated? Well, the reason is all because in your notes it says the atomic emission spectrum. That is, elements give off specific wavelengths of the electromagnetic spectrum. Iron, specifically, when you heat it, it gives off the spectrum in the red region. Okay? If you heat copper, then what you'll find is copper actually doesn't give off red, it gives off green region. Okay? And there's some other elements that give off different colors. And depending upon what colors you see, it depends upon what substance are in there. And a lot of times when people go camping, they'll get some stuff that they can throw inside the fire, and it makes the fire give you all sorts of different colors. What that stuff is it's actually metals from the periodic table that they put inside the fire, that's inside the little canister. And as those metals burn, they're actually considered salts of the metals. As they burn, they give off specific frequencies. And you'll get these frequencies that are in here. The interesting piece is, if you ever watch which one's the most common one in there, you're going to see green. That's the most common one because it's usually copper. There's lots and lots of copper in there because it's really, really cheap. You rarely ever see any other colors because the other colors cost more. If you want to try some other colors, get some table salt. Take some table salt, throw it in the fire, and you'll get another color. If you want to try a different color, go to the store, the same place where you buy table salt, buy some what they call no salt. It's for people that aren't supposed to have salt. Take that when you go camping and throw that on the fire, and you'll get a totally different color because it's a different element. So you get different elements from these different salts. And I'm not promoting the idea you just throw anything inside the fire. I'm just giving you a couple options that you could put in to see different colors. So now, why does this happen? The whole idea behind it is that the last electron in the outermost ring, what it actually does is it actually jumps up. So if we did iron, all right, so I'm going to get rid of this for a second. And actually, you know what? I'm going to go to part number 3 right now because I'm going to run out of time before I get this done and I'm going to miss it. So I'll see you in a minute.